is everything you need to know for the geometry SOL. 3, 2, 1, go. Logic, G1. Conditional statement is if P then Q. Converse, change order. Inverse is when you do the opposite, or you negate it. That's what the squiggle means. Contrapositive, that's the super long word, so you're going to do both. Biconditional is the one where it is if and only if, and you have the double-sided arrows. Your contrapositive is true only when the original statement is true. And the converse and inverse have the same truth value, which means if one of them is true, then the other one is true. The other symbols you need to know. P usually stands for your hypothesis. Q is usually the conclusion. P then Q means if P then Q. The squiggle is not or the negation. The A or the little mountain is and. The V is or, and the 3 dots mean therefore. Law of detachment is when you have one conditional statement and you have a second statement that sounds like the hypothesis of the first statement. The conclusion that we get sounds like the first conclusion. So if we are told if P then Q, and we know that P is true, then we can conclude that Q is true. Law of syllogism. You have two conditional statements, and the first conclusion repeats as the second hypothesis. The conclusion overall that you can make is the first hypothesis and the second conclusion. So if P then Q, and we are also told if Q then R, then we can conclude that if P then R, or you can also conclude the contrapositive, which is something they give you if they want the question to be a little more difficult. Not R, then not P. So a quick example with actual words. If I practice my brain dump, then I will remember my formulas. I practice my formulas. We can conclude that I will remember my formulas. Law of syllogism. If I do my practice questions, then I'll be prepared for my SOL. If I'm prepared for my SOL, then I'll pass. So then we can either conclude that if I do my practice questions, then I'll pass, or if I didn't pass, then that means I did not do my practice questions. Venn diagrams. Anytime they have a statement that is all something, all is going to be your smaller shape. If it is a sum statement, that means, or some of the whatever's in the large circle are also in the small circle. If there's an overlap, sum of one is going to be in the other. And if there's no overlap at all, that means that there is a none relationship. Also, when you have a Venn diagram that has numbers in it, especially one that is like a compound one with 3, what you want to do if you have to answer questions about who is in what, for each category, put a letter that corresponds with that. So for French, we put F in each sector of the French circle. So for the 15, 9, 2, and 7. We do the same thing with an S for Spanish, and we do the same thing with a G for German. And then we can use that information to answer questions about how many people meet a specific criteria. Students taking French, you add up every circle for the French. 15 plus 9 plus 2 plus 7 gives us 33. Students taking both Spanish and German, you have to add all of the sectors that have an S and a G. So you've got the one that is just Spanish and German, but you also have the 2 in the middle. Students only taking German, that would be sectors that only have a G, and so on and so forth. And to figure out the total, you add up all of your numbers. And remember, if you have a number on the outside, that means that is someone that is not in any of the groups. Formulas and transformations. So the formulas that you need to know: slope, distance, and midpoint. You can remember the actual formulas, or slope is rise over run. Distance is the square root of rise squared plus run squared. And the midpoint, you do the rise divided by 2 and the run divided by 2 and use that to find your midpoint. Parallel lines and perpendicular lines and slopes. If your lines are parallel, they have equal slopes. If they are perpendicular, that means that they are negative reciprocals, or that means you flip and switch your fraction. So flip the fraction, switch the sign. If you multiply the two slopes together, it will give you -1. If it is a vertical line, it has an undefined slope, and your equation is x equals a number. If it's a horizontal line, it has a slope of 0, and the equation is y is equal to a number. You can also remember those with Mr. Slope Guy, or you can draw it yourself. That is a positive slope, negative slope, 0 slope, and undefined or infinity to give them a little fancy bow tie. Transformations. Translation is a slide, reflection is a flip or a fold, and a rotation is a spin and a turn. For symmetry, line symmetry means that you can fold it across a line and it is exactly the same. Rotation symmetry means that you can rotate it and it looks exactly the way it did before. Point symmetry is when a figure has rotation symmetry of 180 degrees. Be careful, parallelograms only have point symmetry. You can't fold that in half. A rhombus, however, has line and point symmetry because all the sides are equal to each other. So now on to your parallel lines. Parallel lines cut by a transversal. The two lines, line that goes in between. Remember your vertical angles, alternate interior, alternate exterior, and corresponding angles. Those are always congruent. Vertical angles are across from each other, like the X, like 2 and 3. Alternate interior are 4 and 5. And those are ones like they're on different sides of the transversal. They're inside your parallel lines. Same with alternate exterior, same with corresponding. Easiest way I know to do these is to see if they're equal or not. Put an O in each angle if it's obtuse, A if it's acute. Same letters have the same measure. 2 different letters add up to be 180. So add up to 180 is supplementary. You also have your linear pairs and your consecutive interior angles. To prove lines are parallel, basically see that these patterns verify that they actually show up. Check your angles, make sure that they're congruent if they're supposed to be congruent, or supplementary if they're supposed to be supplementary. Basic things about your triangles. Angles in a triangle add up to 180. Your exterior angle is going to be equal to the sum of the 2 remote interior angles. So if you have an exterior angle like 4, that's also going to be equal to 1 plus 2. So constructions are a place where a lot of people struggle. It's kind of hard to actually perform the constructions on the test, but you need to be able to identify them. If your 2 lines look like they're the same, copy a line segment. That's the easiest one. If you have a line segment, it is a line segment because it does not have the arrows on the end. That means it's a line. You've got a line going through your 2 X's, and if you kind of drew those in, it'd look like a football. That's going to be perpendicular bisector. If you've got a line, so you know it's a line because of the endpoints, and you've got a point outside, not on the line, so point A is not on the line, and it's going straight through, and that looks like it's perpendicular through a point not on the line. Just break your words down and think about what each of them means. And then instead of perpendicular on a point not on the line, we have perpendicular going through a point on the line. In this case, A is actually on the line that we're making the perpendicular line through. If it's an angle and you got the little arc X in the middle of it, angle bisector. If there's 2 angles, or if it looks like there's going to eventually be 2 angles, copying an angle. Or angle congruent to another angle. For your congruent and similar triangles. So corresponding angles are congruent, corresponding sides are congruent. You know things are corresponding when you have your congruency statement. The order matters. A and D go together. B, C, and E, F are going to be congruent to each other because they are in the same spot in your congruency statement. That congruency statement gets written that way for a reason. Ways to prove your triangle's congruent. You have side, 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 where all 3 sides are equal to each other. Side, angle, side. You have two sides and an angle in between the two sides that are congruent. Sometimes they mark it. Sometimes you have one like this where you have your vertical angles. Remember, if you have vertical angles, they won't mark it. You have to mark it for yourself. Angle, side, angle, which is kind of the opposite of side, angle, side. You have one side and two angles next to it that are congruent to each other. For this one, they only give you the R and Q are congruent to each other, but you also need to know that because of your parallel lines, you have the other parts of R and Q congruent to each other, and you have the side that they share that is going to be congruent. The next one you can have is angle, angle, side, where you've got two angles and a side congruent, but the side is not in between your two angles. And the last one is called hypotenuse leg, where you have two right triangles and you have the hypotenuses congruent and one of the legs of the triangle congruent. Remember, just because it's a right triangle does not mean that it has to be hypotenuse leg. And if you count hypotenuse leg as with angles and sides, that gives you angle, side, side. You can't have that. So that cannot be an answer. Similar triangles, proving them works basically the same, except instead of the sides congruent to each other, they need to be proportional. So you want to set up your proportion, do your butterfly. For the triangle inequality, the sum of your two smaller sides has to be greater than the biggest side. So take your two small sides, add them together. If it's bigger than the biggest side, it is a triangle. They cannot be equal, they cannot be smaller than. Your largest angle is always opposite of your largest side. Smallest angle is always across from the smallest side. If you have an isosceles triangle, remember your base angles are congruent. And just anytime you have a triangle and opposite in angles are congruent to each other, the sides opposite of those angles are also going to be congruent. And if you need to find the possible lengths for the third side of a triangle, take those two numbers and subtract them, and take your two numbers and add them, and that's going to give you your bounds. And you want to put less than signs in between. So it can't be equal to those two numbers, but that third side can be anything in between. For right triangles, Pythagorean theorem, a squared plus b squared equals c squared. They give you that on your formula sheet, so you don't need to have it memorized. And if you need to identify if a triangle is a right triangle, plug the sides into the Pythagorean theorem and make sure it works out. If a squared plus b squared is equal to c squared, then you know it is a right triangle. And then if c squared is bigger, you can know it's obtuse. If c squared is smaller, you can know it's an acute. And you also want to make sure that it is actually possible for the sides to be a triangle as well. For your right triangles, they give you a picture, but they don't give you the formulas this way. You want to do SOHCAHTOA. Sine is equal to opposite over hypotenuse. Remember, your angle placement depends on where, or your side placement of your opposite, adjacent, and hypotenuse depends on where your angle is. It's not always in the same place. If the angle moves, the opposite and adjacent sides also move. And if you need to find an angle measure given two sides, you want to use inverse trig, which is when you do second sine, second cosine, or second tangent. Also remember, put your calculator in degrees. It will be in radians when you start. Make sure you switch and put it into degrees. For quadrilaterals, the four main ones that we work with are parallelograms. Parallelograms have opposite sides parallel, opposite sides congruent, opposite angles are congruent. Angles that are consecutive or next to each other are going to be supplementary, so they add up to 180, and your diagonals bisect each other. A rectangle is a parallelogram, but all the angles are 90 degrees, and all of the diagonals are going to be congruent to each other. A rhombus is a parallelogram that has all four sides equal to each other. The diagonals bisect each other, And there's also that angle O, the angle in the middle where the diagonals bisect each other, is going to be 90 degrees. And a square is everything, so it has all of those properties. All sides are equal, diagonals are equal, 90-degree angles all around. Other quads that you might see, you have a kite, which has sides next to it, two pairs of sides next to each other that are congruent, and opposite sides are not congruent. You have a trapezoid where you have the bases are parallel, and you have an isosceles trapezoid that has the two sides congruent to each other, and it also has diagonals that are congruent to each other. So for your polygons, to find the sum of your interior angles, you do the number of sides, which is n minus 2 times 180. If it is a regular polygon, to figure out what each angle measures, you take whatever number you got for the sum, divide that by the number of sides. Your exterior angles always add up to be 360. So to figure out one exterior angle in a regular polygon, you divide 360 by n. And then your interior and exterior angles that are next to each other always add up to be 180. So if you know an exterior angle, you can figure out the interior angle because they are supplementary. For your circles, for your arcs and your angles, you have your central angle, which is equal to the arc. So for that top one, angle 1 is equal to the measure of AB. I call that the Pac-Man formula. You have the inscribed angle formula, where the angle is on the circle. It is equal to half of the arc. I call that the Hungry Pac-Man formula. You have the angle where the two chords intersect inside the circle. I call that the Super Smash Brothers formula. And you just add the two arcs and then divide by 2. And then the last formula is where the vertex is outside of the circle. I call that the slingshot. You subtract your two arcs and divide by 2. You also have your line segment formulas. When you have two chords, you break it up A, B, C, D. A times B is equal to C times D. Or as I remember it, part times part is equal to part times part. That also those pictures will look like your Super Smash Brothers formula. For the two secants, or if it's the slingshot, outside times the whole thing is equal to outside times the whole thing. You also have, every once in a while, you might have one tangent and a secant. Going to be outside times whole is equal to the whole thing squared. Other random circle things that you need to know. If you have two chords that are congruent, the arcs that go around them are congruent. A diameter is perpendicular to a chord. Will also bisect the chord and the arc. If two chords are congruent, they are the same distance away from the center. So in that case, J and L, or JK and KL, are going to be equal to each other. If you have two tangents that from the same point, they are going to be congruent to each other. And the tangent is always going to be perpendicular to a radius. And you can also use that to do your Pythagorean theorem. Arc length, angle over 360 times the circumference. Area of a sector, angle over 360 times pi r squared. So 2 pi r and pi r squared, that is circumference and area. All you need to remember is do your angle divided by 360 and multiply by whatever goes with it. Circumference and arc length, area of a sector and area. 3D shapes. Lateral area doesn't include the bases. That just goes all the way around. Surface area does include bases. That's like if you're wrapping it around. Volume is how much goes inside the 3D figure. Similar shapes, your scale factor is A to B. And then you have your lob chart. Your perimeters or your lengths have a ratio of A to B. Areas have a ratio of A squared to B squared. And volumes have a ratio of A cubed to B cubed. You've got this. That is everything you need to know, given to you in less than 21 minutes. Good luck.